Learning SparkFun with Grant. I think that's what I called it. SparkFun Inventors Kit. Just gonna verify everything's running good on the Twitch here. Sure it's not saying that I'm playing Celeste here still. All right, cool. So welcome everyone. We're once again joined by my friend Zenhaver, who is going to be helping me understand all of this stuff. Last week was a lot of Q&A. I hadn't really slept a whole lot before the last episode, and my mind was all over the place. I actually slept last night, and I think I should be able to focus on actually moving through this kit a little bit better, and my questions won't be so rabbit hole-y. So welcome, Zenhaver. Thanks again for joining.
Thank you for having me.
Yeah. And so when we left off last time, fun thing we get to play with today, I went into a thrift store at an off hour, and being masked as I was still a little concerned, but I found a new toy. This thing is a Celestron microscope, USB microscope, and I think it's going to drastically improve our looking closely at stuffness. We can actually see like little numbers on all of the circuits, and we can like, oh man, it's gonna be great. I'm so psyched. I can also I can take it off of its housing and be like, okay, we're gonna look at this over here, and it's not even at the station, so this should be a lot of fun to play around with. So totally psyched about it. Can you tell I'm psyched about it? So when we left off last time, we were playing around with servos, and I don't know if Zenhaver, if you had a chance to look around online or doing more research on things this week, but I know I
did
watched.
Not do my homework.
I definitely watched like 2 hours probably of different things about servos and servo motors. Still not 100% on it, but you know, we made some progress. I found a few YouTubers that I liked, and I think I have a better understanding as to how things work. I had a lot of trouble this week not diving down Raspberry Pi rabbit holes. My current somewhat obsession is setting up a network accessible storage device via Raspberry Pi. It's going to be cool. I'm excited. So, learned a lot about servos and servo motors. Servo motors are super cool because of the way that they, like servo stepper motors, are just fascinating. Have you worked with stepper motors at all, Jared or Zenhaver?
No, not really.
Okay. They're super cool how they work. Like, they basically have like in every other, like their magnets are, so there's like one set like this, and then another set that's like this, and they take turns powering on to move one step at a time, so you can control how many by via pulse width modulation. You can tell it to move so many steps, and it's like really well controlled. It's pretty neat.
Yeah, I definitely love stepper motors as a concept, and I did not have any idea how they worked until just now, so thank you.
Yeah, we're totally gonna look at diagrams another day. When we did leave off last week, we were playing around with this deal here. I'm gonna plug it in. I think I'm gonna plug it in. I rearranged some chords here. Maybe one moment. Okay. That's the right one? Yeah. So our project last week was, we're totally going to use the microscope, was to spin the potentiometer, which then moved my little motor here, a little servo. So these servos were originally developed and popularized when people were doing a lot of like RC cars and airplanes and things to control rudders and steering components for RC cars and things. And the maker community in general started to really get into using them for a lot of other things. So that's how these got so popular. And there's a whole range of strengths that they have. So there's basically some really cool gear reduction that goes on in the middle of this thing that allows it to have just a massive amounts of torque, just lots and lots of power to move these steering components and things. So one of the demos I saw, someone just put like a stack of books on top of it, of their little servo, and they're able to move the books around just by controlling it, even though it was like a teensy tiny motor. So I've been trying to think about what to make with it. I'm thinking like a button pusher would be kind of cool at some point. Anyway. Okay, so we finished that project last week. So that's project 3A for servo motors. There were a couple different concepts we covered, such as duty cycles for pulse width modulation. I think we'll come back to that again this week, as well as libraries. I did have a chance to poke around at some libraries that were super cool looking. So that's a fun concept that I'm excited to dig into a little bit more. The next project is a distance sensor. So the distance sensor here. Let's see if I can zoom in. I missed my other streams this week, so I'm like, I haven't really spent a ton of time other than teaching in my studio. So I have to like remember what all my buttons do and so the distance sensor project starts off with distance sensors are amazing tools with all kinds of uses. They can sense the presence of an object, they can be used in experiments to calculate speed and acceleration, and they can be used in robotics to avoid obstacles. This circuit will walk you through basics of using an ultrasonic distance sensor, which measures distance using sound waves. That's neat. I've seen these a lot in a lot of other components or projects online. So the distance sensors work by sending pulses of light or sound out of a transmitter, then turning how long it takes for the signals to bounce off an object and return to the receiver, just like in sonar. Some sensors use infrared light, some use lasers, and some, like the HCSR04 included in your kit, use ultrasonic sound. So it's the dolphin sensor. Does your echolocation, maybe bat sensor? Both of those use echolocation a lot, right?
Yes.
Thank you. And also quiz on various biology questions. Thank you, Zenever. New concept, data sheets. When working with electronics, data sheets are your best friend. All right. Data sheets contain all the relevant information needed for a part. In this circuit, we are calculating distance based on time it takes for sound waves to be transmitted, bounce off an object, and then be received. But how can we tell the distance from the information? The answer lies in the data sheet for the distance sensor. In it, you can find the equation the program needs to interpret the distance. View the data sheet at, and it gives me a link I'll have to type in. So data sheets, I think you've mentioned data sheets before, Zenhaver. Is it something that, do all parts come with data sheets? Or is it just modules or?
Basically every single integrated circuit that you can find will have a data sheet associated with it.
Okay.
I use data sheets very, very frequently in my job.
Interesting. Is it pretty uniform? Is it uniform how some of these things work? Like, is a data sheet going to be formatted more or less the same from one company's module to another? Like if we had like 6 of these ultrasonic sensors,
Hmm.
do you think the data sheets would be at least formatted in a similar way or have similar types of information, or is it kind of like a
So
README file?
usually, I think I would at a high level I would put it more as a README file.
Okay.
Each company will usually have like a format or a style that all of their data sheets follow.
Okay.
So from company to company, data sheets will look slightly different. Generally, data sheets will have the same kind of information in them between different parts. So no matter what
Okay.
company you're looking at as far as a chip goes, you can expect to find like timing characteristics, power consumption characteristics, everything that you might need to interface with a chip, you'll be able to find in the data sheet.
That's
They
awesome.
just might be in slightly different places for different chips.
Do you have any companies that whose data sheets are your favorite?
The company that I have read the most data sheets from is Atmel because they provide
Sure.
data sheets for their microcontrollers,
Right.
and those data sheets are large, very,
What
very
are we
large.
what are we talking here? Like
100 pages or something like that.
oh,
Because, like,
good.
a microcontroller has dozens and dozens of registers in it, and each one of those
Yeah,
registers is described in minute detail.
sure.
And there's, all kinds of different topics. So microcontrollers are very complex chips, and so their data sheets end up being rather complex as well.
In your work, do you end up writing data sheets yourself
I
or
have
describing
never
anything like
written a
that?
data sheet. No,
Okay. Is
because
that more on the
we don't.
hardware side?
Yeah, it is. We don't fabricate integrated circuits, so
Okay.
we are usually consumers of data sheets.
Gotcha. That makes sense. Let's while we're talking about it, let's pull up this data sheet. So this one here. So HTTP, not a secure connection. What the heck, man? SFE.io slash HCSR04. Okay, so here's our data sheet for our ultrasonic sensor. That's cool. So it has tech support right on there. So we can follow up with the manufacturer. That's cool. Release 10 US. Is that ultrasonic?
Microseconds. Where could you highlight? Oh yeah, microseconds.
Okay. Microseconds. So that's not a regular U, that's like a.
It looks like in this particular font they are using a regular U,
But it should be
and
like a Greek character.
yeah, maybe technically, yeah, but you would be hard pressed to find many companies that
Hey
follow that stringently.
there, V.E. Kruger. How's it going tonight? Um, Thanks for joining us. Okay, so it has. So wire connecting direct as follows. That's cool. It seems like it might take a bit of skill to read these things,
It's a learned art, yeah.
especially because I'm imagining these words along this side here are probably not completely uniform, company to company. I'm sure they use different.
No,
Hmm,
things like working voltage current, working voltage and working current are pretty well established terms.
okay,
Just from looking at this data sheet, it looks like this is probably a smaller company that makes this specific sensor,
okay,
because this is not quite as polished as I would expect from like a bigger chip manufacturing company, Texas
yeah.
Instruments or something.
They seem more concerned about having watermarks in place than having it look nice.
That seems true.
V. Kruger chimed in with, "Electric Parameter is my favorite Gundam character." Another funny joke from V. Kruger. Thank you. Um, the I'm sorry, that's too mean. I think it was a good joke. I do. There's not enough Gundam themed jokes that happen. Um, so
Yeah, if there's any part of this that like jumps out at you as something interesting to talk more about, feel free to highlight it or something.
Mm.
Otherwise, maybe you would just continue with the project,
The
and we
project, the
can refer
demonstration.
back to this if there's a specific piece of information we need from it.
Yeah, it's yeah, I think that sounds good because this is the timing diagram thing that they talked about in the last one. I'm actually I think I got distracted by uh by the pixelation in the text that I shouldn't be distracted with. So my earlier promise that I was well rested enough not to get distracted was an outright lie, because I was easily distracted by this JPEG artifacting from this text here. So I'll move on. Thank you. Yep. A good point, Zenhammer. So we're also going to learn about else if statements. Cool. In the night light circuit, you used an if else statement to run one set of code when a logic statement was true and another when it was false. What if you wanted to have more than two options? Else if statements let you run as many logical tests as you want in one statement. For example, in the code for the circuit, there is an if statement that flows like this. If the distance is less than 10, make RGB LED red. Else if the distance is more than 10 but less than 20, make RGB LED yellow. Else make RGB LED green. To have 4 or 5 colors for different distances, add more else if statements. Else if statements are different from nested if statements in that only one of the statements above can be true, whereas multiple nested if statements could be true. Okay, that's cool. I've used else ifs a couple times, and so that shouldn't be too bad. So let's take a look at this circuit. Now I'm thinking about anime, Vec. Man, I love thinking about anime. It's great. What series is the electric parameter from, you think? This one comes pre-installed with like a hair or something like that. Maybe it's just a piece of something, but there's like this little, I don't know if it's a bit of silicone or something like that, but I'm gonna try and pull that off.
Oh,
I love that I have
interesting.
this microscope.
It's not actually, that's not in the circuit board itself.
No, it's like an extra thing. I think it's just like an extra wire, maybe? Dropped it. This is the thing. So here we have this is like too zoomed in now. Let's see. Sorry for anyone if this is too much movement. There we go. So here's the ultrasonic sensor. And we have VCC, trig, echo, and ground. There are the 4 wires. I was looking at a bunch of different like knockoff Arduino boards and Raspberry Pis this week. And a lot of the complaints that people had about various modules were that when they didn't fit in a breadboard very well, or the pins didn't line up very well. Is that would you put that as a high requirement for any kind of electrical component?
Yeah, if they're meant to be plugged in into like a common breadboard or
Yeah.
common socket header or something like that, they really need to be built to that tolerance level for sure.
Nice. It's just so funny how ingrained the educational aspect of this electronic stuff is built into like the actual production of these things. I saw a really fun project someone did this week where they had a mini breadboard as a watch and they used a 555 timer or something like that to keep time. Maybe it wasn't a 555, but some other kind of integrated circuit to use as their wristwatch. It was very neat. but it just had a breadboard on it. So it's quite interesting how this whole, I'm a big fan of all these things when there's like these subcultures built into them. And it seems like the electronics folks all have like, it's kind of a fun little subculture in itself. Different behaviors, and I've joined all of the subreddits and things. I don't know how healthy that is, but it's been fun to see the projects roll in. Was there much of a when we were going to school? Was there much of a community at UMD that tailored to this kind of stuff, or was it pretty like still very niche at that time?
Hobbyist electronics stuff
Yeah.
like this, it was pretty niche at the time still. I don't recall knowing of any sort of like hobbyist electronics club.
Sure.
Not to say there wasn't one that existed, but
It's not a popular thing. There's like a lot of people doing it. It's pretty cool.
oh yeah, it's gotten a lot more popular.
I can see why though. It's like it's very satisfying to getting things to work, and it's such a huge. There's so many possibilities. There's like so many things you can put together. It's really your imagination is the limit, because it's not even things aren't even that much money. It's not like it costs a ton of money to get into it. Like $100 gets you pretty far on a project. So that's the imagination part is so hard. Coming up with cool projects, man. Seems like a challenge. So I'm gonna grab my RGB LED here. Have you had any cool projects that you've put together recreationally, Zenhaver?
No, not so much recently. Been a lot more on the old computer gaming kick recently.
It's a good one.
Mm-hmm.
For sure. Especially when there's so many fun games that have you doing interesting problem solving.
Very true. Really tickles that part of the brain.
It's funny how much we like those kinds of things. So this is gonna be just a challenge to get this in place. We're gonna see how well this works with a microscope. I don't know how good this is gonna look or not, but we're gonna try. So the problem is that this LED is like these pins are way too close. I've got to get the first pin in 25, so we're gonna try that here.
One suggestion I might put forward, if I may be so bold, is that you could use a pair of needle nose pliers to actually put like a small 45-degree bend in like a wire, and then another 45-degree bend to bend it back to straight in order to get them spaced out correctly.
Oh, and just have that be
Have it be a breadboard.
a breadboard LED. That is an excellent idea. Thank you. I need to up my needle nose plier game. I only have my Nipix with me, which does a pretty good job. But so let's see how well we can do this. You think it weighs up the pin about halfway? You think?
I would put it a ways up, yeah. Maybe even like 3/4 of the way or something like that. And it doesn't need to come out super far.
I probably took your 45-degree recommendation too much to heart. Let's see here. Yeah, the key is to get it all spaced right. I'm gonna have the yeah, that looks pretty nice. I'm gonna have the ground pin be completely stationary, I think.
That sounds like an excellent idea.
That's the longest one. Even this is like pretty satisfying work.
And it doesn't, yeah, it definitely doesn't need to be like perfect. Just getting them even grossly in the right spot will make it
Yeah,
10 times easier to
a
insert it.
world of difference. Yeah. So where Grant spends 30 minutes trying to bend these perfectly. But here's what we got. So here's our bending. I think that works
That
pretty
looks
well.
great.
Cool. So now these will go in quite well. So there needs to go, the ground wire is going in on 24. Oh, that was a great suggestion. Thank you.
Are they long enough to actually get all the way into the breadboard now? That was something I didn't think about. If you bent them a little too severely, the pin may
Yeah,
not reach all the way down to the socket.
yeah, I believe it is. It feels pretty snug.
Excellent. Yeah, that looks great.
We'll find out soon, right?
Yes. You would, if it didn't work, you'd have to maybe snip the ground wire just a little bit shorter or something like that.
Yeah, and I could see maybe needing to do that actually, because it is, quite a bit longer.
You could,
Uh,
yeah, you could snip them all to be the same length, and then like take a Sharpie and color the ground wire black or something like that.
oh, that's a problem, isn't it? And I don't have a wire cutter with me down here, which I'm hoping to remedy quite soon. I have a flush cutter that I use for zip ties sometimes, and that's upstairs. But we'll try it. If it doesn't work, then I'll run up there and get it. So we have an LED, which means we need resistors. Let's get our resistor kit out. I was looking at some storage solutions for different things, and I'm definitely leaning towards the Harbor Freight parts bins. They have like a parts bin toolbox thing that I've used for like leather crafting supplies. That seems like it will work quite well. I only need resistors across the live pin, so I don't need one for the ground. So only on 26, 24, and 23. These are the 330 ohm resistors. Ah, geez. I bent it. Oh, God. I think I'll have to pull up a picture of that wristwatch. Did I send that to you this week? Okay.
No, I don't think so.
Oh, yeah, we'll have to look at that. It is extremely dorky. I kind of love it.
My favorite kind of project.
Yeah.
A very dorky one.
Mm-hmm. The best kind. If it's too useful, then it's not fun. I say that as I try and think of the most useful things I could do with this. I'm totally guilty of like making things overly useful. That sounds really like I have an
That's
enormous head.
that's like what is talk about one of your weaknesses, Grant.
Yeah, right. Yep. Where I can't get maybe a better way to say that is that I have trouble thinking of not serious things to use these things for, and silly things kind of escape me. Is that better? Is that less of a? That's still kind of one
Yeah,
of my weaknesses. Dang
still
it.
a little bit, but a little bit better.
Thanks. I'll have to work on that. That just in general, not related to electronics. Um, oh dear. Okay, we're gonna send our ground pin to the ground rail. And then we have a blue and a green wire that are going to go to a couple of the digital outputs. Red, green, and blue. After the resistors, red goes to 3. Green goes to 5. Let's see. It just tells me. kind of hard to tell in this diagram sometimes. They leave 4 open. That's interesting. So they chose to, on the diagram, have it be so they because they skipped 1 for the ground over on this side, they skipped one of the digital outs over here, so they're not going to number 4 as digital out. Actually, you know what it might be? That's not why. I think it's because the 4 digital out does not have any pulse width modulation, right?
I would say that's correct. I would say that would be a good reason to use different pin. Yeah.
So 3, 5, and 6 have pulse width modulation based on the tilde.
Yep. Checks out.
Cool. All right. I love when things are done for good reasons. Three goes to 6. Okay, cool. So I got that done. I'm going to once again put the 5 volts and ground up to the very top of the rail because that just makes more sense to me. So one of the things I've seen this week is people talk about 3.3 volt things instead of 5 volt things. What can you tell me about that? Like, why is there such a split? Why did they choose to complicate by having 3.3 volt things?
There is not an easy answer, or at least not
Okay.
an easy answer that I'm aware of.
Sure.
Some electronics, I think, will work better at lower voltages.
Okay.
Yeah, I don't think I can give you more info than that.
I mean, aren't all of these lower voltages, or is is the difference between 3.3 and 5 that much with these kinds of things?
It is. It
Okay.
is. And I think I am just gonna have to leave it at that.
Okay.
That might be a good topic to dive into another time.
Okay. Not
And
bad, huh?
to be clear, it's not as much that it's just way too complicated. It's more that I just don't know.
Sure.
So
Okay.
that's not something that I know a lot about, like why you choose 3.3 versus 5 volts when designing a system.
Yeah.
I know a lot of different breakout boards and kits on SparkFun will come in
Mm-hmm.
both 3.3 and 5 volt flavors.
Yeah.
So it's certainly capable. You're certainly able to design systems around both.
Mm-hmm.
And you kind of just need to know at what logic level you're operating at
Because
when you're
Raspberry
designing a
Pis are
system.
usually 3.3, right? Or do they do 5?
I don't know the answer to that either.
Okay. I'm sorry. I've like dug into so many hardware, like looking at so many modules and stuff this week.
Hmm.
I've got a lot of hardware stuff in my mind. Um,
Yeah, that makes sense.
I will dig into it though
It
and
is.
see if I can come up with a good answer.
It is like I said. It is important. You need to know what power level you're going to be supplying to a board because even when you're thinking about something like an LED, right? Like that 330 ohm resistor that we're
Yeah.
picking for an LED, that
Yeah.
in part depends on the voltage that's being supplied to the resistor or to the LED. And
So
so
in
if
like
you're
a
doing something
three,
like shining an LED, you need to know whether you're at 3.3 volts or 5 volts in order to know what resistor to pick.
sure, it's so you need a smaller number of resistor for 3.3 volts, right?
Yeah.
Just looking at the old equation, how that all
Mm-hmm.
works.
Mm-hmm.
It's cool. It struck me as such a strange thing because of how seemingly obsessive with standardization this industry is.
Even having those levels of 5 volts and 3.3 volts being defined as they are is a level of standardization, right? You
Yeah,
don't
it
have
is. Yeah.
systems out there that are 4.3 volts and 3.7 volts, and
Yeah,
pretty much everything works at one of those two logic levels.
absolutely. And it's impressive how stringent the all these things are that you can get things manufactured at many different levels and qualities for very small price tags for individual components and have them be standardized at all. I think it's just impressive. Um, it's I'll have to see like what the main purposes are.
If I had to venture a guess, if you will come with me on a journey to the land of speculation.
Sure. Yeah, I'm there all the time.
So circuits, in essence, are all just about turning transistors on and off in very special and unique ways, right?
Yep.
Transistors are very much spec'd to certain power levels. I would suspect that if you built your system out of 3.3 volt transistors
Mm-hmm.
that have less power going through them, maybe those transistors can be made more cheaply than a transistor
Mm.
that um,
Okay.
is spec to be able to handle 5 volts of power applied to it. Maybe the characteristics of those 3.3 volt transistors are better for certain applications, like maybe they're speedier and they turn on and off faster so that your circuitry is more responsive.
Yeah. And I mean, so there's also like the power consumption part of it, right? Like because for a resistor, it takes some of the the electrical energy and converts it into heat, right?
Yes, that is true of an LED, yes. A
Excuse
very,
me. So
very small amount of heat, but non zero.
I mean, if you're gonna put all these like a bunch of resistors on your components anyway, I could see like why not just lower the voltage and require less resistance.
Now, now, power is actually mostly a function of current,
Okay.
and the purpose of the resistors is to limit the amount of current flowing through the LED.
Yeah.
And so when I said you would pick a different resistor value for a lower voltage circuit,
Mm-hmm.
you would pick a different resistor value so that you had the same amount of current flowing through an
Yep.
LED as if you were using a higher voltage system,
Yep.
because the amount of current flowing through an LED dictates how bright it is. And so if you were
Mm-hmm.
trying to match brightness between a 3.3 volt system and a 5 volt system, you would try to match the amount of current that you have flowing through that LED in the two different circuits.
Good old Ohm's law.
Yes.
Um, okay. Yeah, I think that makes sense because people are talking about for like really low powered Arduino things that going with 3.3 setup was better, just because it consumed less current, which I think checks out, right? Kind of.
Checks out. I think that checks out. A lower
Okay.
voltage Arduino would definitely consume less current.
Yeah.
It all depends. Yeah, it all depends on the application.
Sure. Because the current is kind of drawn through. However many things you plugged into it, it'll be able to pull current. However much is being used. The voltage is. Oh god, I should just stop. I'm gonna get confused. Um,
You're on the right track.
and so the voltage is how spicy it is, and the the
Oh no, you lost me. I'm gone.
okay, okay, um, yeah, we'll work on that one. I think I have all the components plugged in, so I'm gonna plug this sucker in, and we're gonna load up the sketch. Okay, get out of here, datasheet. Find this thing, which still has the one open from last week. Circuit 3B. Okay. And I'm going to upload. I don't know if I said hello, Lampshade. Thank you for joining, Lampshade. Hope you're having a fine time. So here we have some things happening as I move my hand. So we have our LED is red when I'm close. It's kind of confused. Yellow when I'm a certain distance away. And then green when I don't have anything in that place. I bet this works better with more solid objects instead of hands. Just based on, I had a while ago, I had an ultrasonic measuring tape that worked so. And this is kind of just changing values quite a bit. So I think the LED is functional. So we got all the colors that we need from there. So let's take a look at what this is doing. So, okay. So const, I've not seen const before.
Declares that variable as constant and will not allow you to change it, or will give you an error if you try to set it to something else in your code.
I'm correct in saying we haven't seen this before, right? In these
I think so.
sketches?
I don't remember seeing it.
Okay. Okay, that makes sense. So here's the setup. So here's the serial connection. Ooh, let's open up our serial monitor. So we can shoot this across the room. Wow, that actually has a decent amount of range. Pointing this kind of around the studio here. Yeah, that goes a ways away, huh? That's cool. Neat. So there's our serial plotter. Okay. So trig pin is the output. So trigger pin will output pulses of electricity. So this is probably the ultrasonic sound. And this is the input. Echo pin will measure the duration of the pulses coming back. So where does that go? Back from the distance sensor. So one thing I'm noticing with this is that this is not inputting into an analog in, it's inputting into a digital in, which prior to this project has only been showing ones or zeros, right? It's only been true or false on the digital inputs. So is there something else happening here that's able to give it an actual number?
I suspect that the datasheet would actually be able to tell us exactly how you would measure what
All
echo
right.
pin's input will be.
Okay. Modules include ultrasonic transmitters, receiver, and control circuit. So using IO trigger for at least 10 microseconds, you said?
So that's telling us that in order to trigger a measurement, we need to set that trigger pin high for at least 10 microseconds.
Okay. High level signal. Okay. Is that just to kick it off, or is that just like an always thing?
That seems like once you trigger the trigger input, and we could confirm this by going and looking at the timing diagram.
Yeah.
That once you hit that trigger pin, it basically will send out those 8 pulses.
Okay.
So it says send the trigger level high for at least 10 microseconds.
Mm-hmm.
And then after that, the module will go off and send those 8 pulses to measure the distance. And then once it's done with those, it will bring the echo output high for a length of time that is proportional to the distance that the
Oh,
module
okay.
thinks is something is far away from it.
So it just turns on high for a certain amount of time.
Yes.
Okay. And then that's what we use to calculate the actual distance.
Yeah, the important part there is you can calculate the range through the time interval between sending trigger signal and receiving echo signal, and it gives you the formula used to calculate it.
Okay. That's this bit right here. So when I'm shopping for components in the future, would it be smart to look at data sheets before I buy anything?
I would basically never buy something without looking at the data sheet first.
Okay. Because it could just be kind of nonsense or not actually explain in the product
It
description what it does.
Usually if you're shopping for something, you have a specific application in mind or a specific use, and
Yeah,
you would be looking at the data sheet to make sure that the part fulfills whatever use you have in mind for it.
that makes sense. Data sheets over product descriptions. So, okay, here's our setting our outputs for the RGB LED. Here's our serial print. Print the distance that was measured, okay. Print inches. If distance is less than 10, okay. So this get distance function is someplace else, right?
I would suspect that it's towards the bottom of this code
Okay.
file.
I'm still kind of struggling with the functions being called ahead of time thing, but I'll get used to it. Or not being called ahead of time, I should say. Okay, so let's go find that because that'll make more sense to me. So here's get distance. Ooh, a float. That's cool. That's floats are decimal numbers, right?
That is correct.
Float. Okay, echo time. Hmm. And I imagine too, if I had a device like this, a circuit like this, not only would I find things on the datasheet, but there is probably 100 tutorials on how to use it online.
Oh yeah, most certainly. At least for anything that you'd buy from SparkFun,
Sure.
I'm guessing there's going to be a lot of resources out there.
Yeah. Help with those. So set it to high, set a delay. So this is before it does anything, it's gonna have the 10-second microsecond thing, and then write it to low. Then that's gonna start the 8 pulse thing. So pulse in, and is pulse in a function?
I suspect that if you went to the Arduino reference library, you
Yeah.
would find pulse in as a built-in function,
Okay.
and it looks like the comment describes what to expect from pulse in.
Okay. That's cool. Okay. Calculate distance, echo time divided by 148. Calculate the distance of the object with pulse. Half the bounce time multiplied by the speed of sound.
And that 148 looks like it came directly from the datasheet.
Yeah, I think so. The equation was down here, right? Yep. Cool. Nice. So we could change this to centimeters by swapping this out and swapping the label at the other portion. That's cool. That's neat. Okay, send back the distance. That makes sense to me. Anything they're asking us to try. Change the limits of the distance sensor. So we can change the limits to, that's just over here. So this is still reading in feet. Or inches, sorry. So 10 inches, more than 10 inches, less than 20, or too far away. So we could easily change this to, 30 inches here, 30 to 50. And then if I upload this, it should be a lot more wide of a range. So, so green, if I look at stuff that's far away, it should change to yellow, looking at other, this is looking at another part of my studio, or red if I put my hand in place. Cool. What I kind of want to use this for is look at like, I want to measure the height of plants as they grow and maybe use that to set the height of the light platform that I'm going to build in my greenhouse project. So it'd be fun to do like, you know, if distance is 5 inches, you know, it would be, instead of turning on the LED, it would be running a motor or something like that to move the light bed up and down. Could be kind of cool. I don't know if I would need an else if, but I might just need a one mode something, but neat. Well, I think we're done with this project, huh? Sorry I don't have so many engaging questions this time, Zenhaver. I think I got a lot of them out of my system last time.
That's totally fine.
I hope you're not too bored. I don't have that many
not at
questions
all.
today. Okay. All right. So this next project is the motion alarm. So, that should be fun. So the motion alarm project. Time to take your distance sensor project to the next level. Let's imagine you want to stop your cat from prowling around your countertop. Yeah, that'd be great. I don't have a cat, but it'd be great. This circuit uses light, sound, and motion to scare away your cat when it is detected by the distance sensor. Using a servo motor, you can add a moving pop-up to animate your alarm. That's great. So, new mechanisms. So, this circuit gets really fun when you start to use your servo to animate the world around you. To do this, you'll need to connect your servo to some physical mechanisms. Tape and hot glue are easy ways to connect things to your servo. You can also add a loop. You can also loop a paperclip through the small hole of the servo arm to serve as a linkage. Assembly. If you have opted for the extra materials, use the following instructions to create a moving pop-up for your motion alarm. I don't know if I do have any extra materials. Looks like it has a cutout of a cat that I might be supposed to make. I don't think we're gonna do this. We'll just have our servo do something, but so we're gonna actually skip past a lot of this stuff because this is just adding some control to the servo. Doesn't really have a lot to do with electronics. And it looks like this is a very similar diagram. I usually pull these things apart before I move on to the next project, but this one is very similar, and I think I'm practiced enough at the breadboarding for now to be comfortable just adding some of this stuff in. So we're going to add the piezo buzzer. Am I saying that right? Piezo? Piezo?
Piezo.
Piezo. Piezos are cool. And it is polarized, so we're going to put the negative on the negative. So, okay, so this goes here. I'm going to power down before I do anything, right? I almost didn't. I almost forgot about that step. So this is going to go at 16. You know, I don't actually have much left. There's like just a couple more projects for this whole thing. There's 5 projects total, it looks like. Cool. We're getting there. I'm really excited. I'm a little like, I'll be bummed out to finish this, but I'm kind of excited to graduate, as it were, and move on to some other projects as well. So let's get our white, black, and red. Do you have any recommendations for other kits or other things I should get my hands into once I'm done with this kit?
That's a great question.
I guess we'll have to see what this one teaches us, huh?
Yeah. I don't know so much about other kits. You know, SparkFun obviously has a lot of cool sensors and stuff, but Adafruit is another website that I have browsed and purchased different boards from and different sensors. So they might be another resource to go check out.
I wonder if it'd be worth doing like another Arduino starter kit, or if I should look into other technology.
Yeah, it's probably going to rehash a lot of the same topics that this one does. You know, the very basics of like how to hook up a circuit and what
Yeah,
some different things mean.
might be a bit redundant. At least in the parts that I get, I'm sure it'll be quite redundant.
Yeah, that's probably true.
So, okay, we have our servo hooked up to pin 9. We have our piezo buzzer set to pin number 10. And the the positive and negative for the servo, and the negative hooked up for the piezo. So this is all ready to go. I really appreciate how comfortable I feel with the breadboard at this point, where I'm
Yeah,
not
this
quite
is
as
a
intimidated by it.
pretty fairly complex circuit, and it seems like you've got a real handle on how all the different pieces are connected together and stuff. So
It's good. It means it's working, right? It means that the guide is sinking in at some point. Maybe that's what
the
that means.
knowledge is in your brain. It's
Nice.
inside of you.
Inside of me. I've absorbed it. Um, okay, so let's upload this thing. So let's upload this thing. There we go. Okay, so what is happening? So we include the servo. Oops. We include the servo library here. Here's setting the trigger pin and the echo pin for the ultrasonic sensors as constants. The constants for the RGB LED for those pins. Constant for the buzzer pin. So question, do pins always need to be integers?
I think the functions that you are using the pins as inputs to probably expect an integer. So in that sense, yes, they do need to be integers
Mm-hmm.
because you need to pass the data type that the function expects as a parameter.
Can the pins natively accept anything other than integers though?
Hmm. Functions are pretty strict in that they only will accept the data type that they are declared as being able to accept.
Okay.
It's possible that the system may be able to do some implicit conversions between data types. So if you were to stick like I'm trying to think of an example, a byte, which is like an int but is a smaller
Okay.
data storage type, it's
Mm-hmm.
possible that it would be able to implicitly convert that byte into an int.
Okay.
But technically speaking, you can only pass ints to functions that expect ints.
Okay. And these functions are ones that these are custom variables though, right? These are ones that are baked in.
Yes. Yep. Those are user defined variable names,
Okay.
but they
I
are
think.
all standard data types of
Mm-hmm.
integer.
Okay. So float distance set to 0, just declaring the variable. Servo my servo. It's a servo object, and this is servo is highlighted right here because we are bringing in the servo library, right? I think I asked this exact question last time.
Yeah, a complex class, which is probably why
Mhm.
it's highlighted in red there.
Okay, serial begin. This is the serial connection. Setting the pins to inputs or outputs, respectively. Attaching the servo to pin number 9. So here in serial, we're printing the distance in inches. And we have the same thing with the if else if statements. So being less than or equal to 10 inches, between 10 inches and 20 inches, and greater than 20. But they just added a few other things to it. So we added a buzzer tone. So no tone if it's close, I think. Wait a minute. Okay, so gotta read this again. Oh, this is turning off the buzzer. Okay, so turn the buzzer to 272. So buzz the buzzer for a little bit for 100 milliseconds, and then turn everything off. Okay, that makes sense. So that only happens at this range. So this is the actual triggering of those things, the servo and the buzzer. And then here's the other parameters. Delay 50 milliseconds between each setting. What if your cat is faster than 50 milliseconds?
My God, you have a demon cat.
Yeah, then you have more problems than you can deal with. Here's the get distance thing. This is the exact same as last time. So the pulse of 10 microseconds to get it to send off. And it has to do that pulse for 10 microseconds every time it takes a measurement, right?
Yes.
Okay. Your calculated distance. Okay, cool. So just to show this thing off, what it does as you get closer, it wiggles your servo and buzzes as things are close. I think it would just attract the cat, if anything. Cool. We are done with project 3. It is 9:06. Mr. Zenhaver, are you cool with hanging on until 10?
Yes.
Excellent. Let's pull this sucker apart. Although it is soothing to have an alarm.
Seems like it was really flailing at you to try to get you to stop from pulling it apart.
Yeah, please no.
It had gained some sentience.
I want to live. Come on. Okay. And just so look, I kind of want to take just a peek at the back of this sensor and see what else we're dealing with here. So this has on it, this is a Texas Instruments, right? That's the Texas Instruments logo, right? I believe. LM324.
That is a quad op amp integrated circuit.
Nice. Thanks, leading musicians. A quad. How do you know that? Is it just
I looked it up. I do not have an encyclopedic knowledge of all integrated circuits in my brain, unfortunately.
I was so impressed there for a second. I'm still impressed though at your fast googling. And then these ones aren't labeled.
That is pretty funny. I'm surprised actually to see unlabeled ICs on a board like this.
And they're different sizes too. This one's bigger.
I guess they could be like application specific integrated circuits, custom made for this module.
Yeah.
It's tough to say. It almost looks like they've been like scraped off or something, like it's been sandpapered or something.
Lightly used. And there's also this on C8. There's no numbers on C8. What are these things?
Those are resistors, and I believe C8 is a capacitor.
Oh, for C. Yeah, okay. R.
So those would be surface mount resistors and surface mount capacitors.
Okay. It's not using colored banding, but numbers?
Correct.
For the, I think that's a 335.
Yeah, that sounds about right. About, yeah,
That was a dumb question. This one's upside down.
So it is. It's funny that they're both 103 ohms, but one is upside down, the other one isn't.
Well, this is interesting. Cool.
Like the way that these circuit boards are made is that they have machines that called pick and placers that will actually
Okay.
like suction up each part and put it in the spot that it needs to go.
Okay.
I suspect that they get the resistors and capacitors in a reel from the manufacturer, just sorted all different which ways, or like in a line, but in completely random orientation, and it probably
Yeah.
just picks them up as they are and sticks them down.
That makes sense. Because it really doesn't matter because it's not polarized. So
Correct.
why would they care enough to put in, to lower their throughput on their machine?
Correct. Now, some capacitors are polarized. It's important to note.
Oh,
There are some capacitors that are not, so it's important to know kind of which one you're working with.
interesting. Is there like a rhyme or reason as to why you would use one versus another, or is it just dependent on the parts that you choose to use?
They they are physically built different, and I believe that really big capacitors you need to have the polarized kind.
Okay.
I think just by the nature of how they're put together.
How they
I don't know
capac.
more details than that. Yes.
All right, these jumper wires are too all over the place. Leading musicians, did you get a chance to try out streaming yet? You're still working on OBS. These are a little bit more organized. That'll help my brain work better. Okay. And we gotta put away our piezo buzzer. Get in the bag. Okay. Back to square one. All right. Printing data to the Arduino serial monitor is a great way to see data from the breadboard. But what if you want to make your project mobile and see sensor values away from your computer? This project will show you how to do exactly that. You'll learn about liquid crystal displays and how to print things like sensor data and strings of word to the display. Yes! I'm so excited about this. So we're going to learn about new components, the liquid crystal display, the TMP36 digital temperature sensor, and the 4X AA battery holder. New concepts introduced in this project: contrast, pixels, algorithms, button debounce, strings, pointers. And I will learn how to print simple messages to an LCD, how to use a temperature sensor, how to print a sensor data to an LCD, and how to make an interactive game that incorporates the LCD. Cool. All right. I've been so excited. This is one of those things where I kind of got like some of the other components. I was like, oh yeah, of course that does that. But how to get the stuff that we've done so far to like an output for a display still makes absolutely no sense to me how that might function. So I'm very excited to learn about this. I can get this out of here. There we go. Cool. This was like just manufactured not too long ago. On August 8th was this manufactured. And it passed quality check, which is great. Good news there. Okay, we can't actually see any of the fun bits because they seem to be all in the other side. We can't see any of the interesting, like what kind of integrated circuits it has, but that's okay. So I'm just going to set this down here. So new components. Character liquid crystal display. Designed to show a grid of letters, numbers, and other special characters, LCDs are great for printing data and showing values. When current is applied to this special kind of crystal, it turns opaque. This is used in a lot of calculators, watches, and symbol displays. Adding an LCD to your project will make it super portable and allow you to integrate up to 32 characters of information. Excuse me, drink too much water. New concepts. Contrast. Pin 3 on the LCD controls the contrast and brightness of the LCD. Using a simple voltage divider with a potentiometer, the contrast can be adjusted. As you rotate the knob on the potentiometer, you should notice that the screen will get brighter or darker and that the characters become more visible or less visible. The contrast of LCDs is highly dependent on factors such as temperature and the voltage used to power them. Thus, external contrast knobs are needed for displays that cannot automatically account for temperature and voltage changes. That is interesting. I did not know that. If you look closely at the characters in the LCD, you will notice that they are actually made up of lots of little squares. These little squares are called pixels. The size of the display is often represented in pixels. Pixels make up a character in space, which is the number of pixels in which a character can exist. That didn't make a lot of sense. Let's try that again. These little squares are called pixels. The size of displays is often represented in pixels. Okay. Pixels make up character space, which is the number of pixels in which a character can exist. Is it just me or is that super confusing?
It sort of assumes that you know how a character-based LCD works, which
Okay.
it really hasn't done a good job of explaining up until this point, so it is confusing in this context.
Is character in this context, does it mean like a letter? Like a
Yes, like a
C, A, B, C, D, E?
yes. Mm-hmm.
Okay. And so is this kind of display exclusively built for displaying characters, or can it display anything?
This specific module, I believe, is built specifically to display characters.
Oh,
Like it
interesting.
breaks up the LCD, the actual display into two rows of 16 characters each, and that's how you like write data to it and tell it
Okay.
what to show.
As opposed to like saying, put, this pixel's on, this pixel's off across the
Yeah.
whole thing.
Hmm.
Okay. Neat. I had no idea that that was a thing. But I guess like watches, that makes sense for like digital watches and stuff.
Yeah, think of like a 7 segment LCD, right? Like the really old timey.
Casio watch.
Yeah, that is like one form of a character LCD, right? It's like a display that is very
Yeah.
purpose driven to display a single character by showing 7 different segments that are either on or off. This is sort of an extrapolation of that to say, okay, we still want to display characters, but we're going to make them a little bit more well defined.
And have you worked a lot with displays like this?
Yes.
You have. Okay.
I mean, not specifically character displays. I've used these in my past hobbyist projects.
Sure.
My my actual job, we work a lot more with the more typical, 128 by 128
Right.
pixel
Okay.
displays. Yeah, that
And
are
those
just
function, I'm sure, in a very different way.
yeah, they're a lot more like a computer monitor, right? You just tell every individual pixel whether it should be on or off.
Okay. Neat. This is actually kind of a complex breadboard thing. This will be good. Good practice. It's kind of a nice progression because I was, as we all remember, moments ago saying how comfortable I am using the breadboard, and I think this will be a nice little challenge. So, so we're gonna, you know what? I'm gonna zoom out just a little bit. That's what we're gonna do. See if we can do this without showing too much skin. That is so much better. Oh, why didn't I do that weeks ago? Goodness. There. Now you can see the whole deal. If I can move I'll adjust my head here. My wife is walking around upstairs, which shakes the floor, which shakes the camera that's bolted to the ceiling in the basement. If you're wondering what the quaking was from. Okay, so here is our LCD, and we're going to start this. The very first pin looks like we're going to start on it says over here. This the very bottom one is ground. We're going to start that on B30. We're going to do A30 because why not? Oh, this makes me nervous. Getting this in. There's a lot of force you have to apply to these things. Get them in place. Is that common?
I am not surprised that this one has a lot of force required. You know, every
It's a
one of those
lot.
pins requires a little bit of force to push in, and you're trying to push in a lot of pins at one time.
Just trying to like press in on my fingertips. It's no bueno.
You could try like sort of more firmly pushing on one side to try and get those ones sort of partially inserted, and then sort of push it in on the other side.
There we go. That's sound advice. I was able to rock it back and forth to get it in place. Cool. All right. Neat. Okay. Get our potentiometer in there. That is the piezo buzzer. My gosh. Okay, so this is gonna go, it doesn't matter where it's gonna go because there's not many things on here. So I'm just gonna plug it in, facing the proper direction and note which pins are what. Right? That's the appropriate thing to do.
Yeah.
Not just follow the explicit instructions, but actually
Yeah.
own it a little bit, you know?
More power to you, I say.
Thank you. Specifically 5 volts, right?
Not more than 5 volts worth of power.
Uh, 5. We got our 2 rails set up. And we're going to plug in the ground and 5 volts. Nope, that's not the right one. So Zenhaver, what has consumed you on YouTube this week?
Oh man, my YouTube rabbit hole has led me to watching a channel in which a guy finds various scrap metals and melts them down into ingots,
Oh,
aluminum ingots, copper ingots, all that sort of thing.
that's cool.
That has been quite enjoyable. I've also been watching a lot of videos on how to solder copper plumbing
Oh,
in order
that sounds
to prepare for a couple little house projects that I've been putting off for a long time.
gotcha. What projects might I ask?
Oh, a couple. Let's see. I have a shut off, like a ball valve, which is acting as a shut off to an external spigot that every time I go to turn it off or turn it on for the year, as it gets warm or cold, it always is tough to tough to really get into one position or the other without it leaking. So I've
Sure.
got a mind to replace it. I would also like to replace the other external spigot at my house, since the handle is broken.
Oh, those sound like some good projects to take care of.
Yeah.
Are those good? Um, yeah, I know. That's my wife is walking around upstairs back and forth, and so um, that's just. I need to put like a rubber gasket or something like that between my camera and the flooring. Yeah, I know. I really should make a shock mount. Maybe that'll be a Thursday stream. Is I'll fabricate a shock mount. Um, those sound like excellent projects. Are those fairly high risk projects for leaking and things, or not so much?
They are, in my opinion, some of the simplest copper soldering that could be done.
Okay, that's good.
So I feel like they would be some good intro to copper soldering projects. And if all else fails, I mean, my whole house water shut off works just fine, so I can always just shut
Nice.
everything down.
That's good. The oh crap handle.
Yes, absolutely.
Here's my hat. I did it. I did the thing, everybody. Dang it. Lean too far forward, and now my camera's not in focus. And I just plugged in my 5-volt to my ground because I was worried about my camera.
Get it together, man. You're gonna blow this place up if you don't pay attention.
I know, right? We do have to make me a shock mount, V. Kruger. That's a great idea. Oh, okay. Maybe we'll switch to microscope mode, and we'll kind of watch what I'm doing with that. That's probably not going to be much better shaking wise, though. Now that I think of it, but maybe I'll be able to give a tour. This is terrible. Why would I do this? That's not going to work at all. Never mind. Okay. Ugh, too many camera angles. Okay, so we're missing just a few more things. So we need to put on the various cables for the potentiometer soon. So we'll use this green one. We'll go to the center pin on the potentiometer. And we're going to do the hot and ground. Is it all right to say hot, or should I say 5 volts?
Hot would be fine. Power or 5 volts is probably more technically accurate.
Okay.
Well, not even technically accurate, more commonly understood in this context.
Okay. You know me, I love learning the pedanty. Is that the right term? The pedantic ways of referring to things? It is now, yep. How very unpedantic of you. I want pedanty to be a word, though. That's good. Okay. This goes up over to 11. This is kind of hard to wire. Right. This actually goes to 12. Oh, okay. So we have too many wires here. There's 1, 2, 3, 4. Counting up from 8. So this does go to 12. Okay. This is not a simple wiring thing. I'm kind of liking it. But it makes sense. So how? It's got to be quite a few wires to do like a standard 120 display, doesn't it? Like a regular pixel grid?
Yeah, yep. It probably is.
Are those even controllable from an Arduino or not?
It depends. It depends. Like a lot of those more complex displays will have some sort of driver circuitry built into it that will perhaps let you address individual pixels using, 1 byte of data to indicate like which row and which column you're trying to write to or something like that.
Okay.
It really depends on the display itself, I would say. Like if you had a display that you could just communicate via like SPI to, you could have just 4 wires going to that display to communicate via that digital protocol, except you would need
Hold
to
up, my
spend
audio
time.
plug. I can't actually hear you. 1 second.
Okay.
I lost you at SPI.
So if you had a display that was built using an SPI interface, you would
Okay.
need just the 4 wires to communicate via SPI.
Which is like
And
the quick connector, right?
that is what the quick connector uses, yes.
Yes!
And then you would just write like the entire screen's worth of data over that interface rather than like using a line to address individual pins or something like that.
And that's more of like a regular like data connection then at that point, less of
Yes.
a
I would suspect that this board is using some sort of digital interface like that.
it does have it does have a quick connector on it. Somewhere here. There we go. There's the quick connector, and that's probably how it's using the serial stuff too, right? Like, was that what does SPI stand for? Actually, I
Actually,
forgot first.
quick might be I squared C. SPI stands for Serial Peripheral Interface.
Okay.
And the way that quick is spelt, QWIIC, makes me think that it's actually uses the IIC
Okay.
digital interface.
We're not quite there yet, are we?
We will probably need to be as a part of this project. I suspect that this project will try to tell you about digital interfaces, perhaps.
Cool.
Not sure.
We're all hooked up. Ready to plug in. We have to turn the USB cable right side up though, in order for that to work. Okay, so let's find my cursor. That's step 1. File open. Project 4, LTD Hello World. And upload. Okay. So this is now uploaded. So, okay, so include liquid crystal library. Standard library, that's cool. So this says the pins that are attached to liquid crystal. Are those in any particular order or just the general? These are the pins that are attached to it, and then we sort them out later, probably.
I'm sure that it's a specific order.
Really? Okay.
Yes.
I wonder if I should look up the data sheet, right? That would be a thing to look at for that.
Maybe. I bet if you tried to find the liquid crystal library, actually, it would tell you what it is expecting for each one of those inputs.
Okay. Oh, it just says, okay. Set cursor at 0, 0, print hello world. It's cool. Does it say that?
This looks like a pretty advanced or like a pretty user-friendly library for this liquid crystal display.
Yeah.
I bet that there's a whole lot of stuff going on behind the scenes in order to support like this whole setting of cursor and just printing strings right onto the display.
We're getting exactly nothing on our display.
Try twisting the knob a little bit to see if the contrast is too high or too low.
Oh, there we go. Still getting not words. I'm going to unplug it and verify that I plugged everything in correctly.
Let's debug. Oh, baby.
Oh, baby. Okay, so
the manual has a description of what each pin should be used for. Could you perhaps side by side the LCD and the manual?
I could. So I don't know how clearly we're going to get the words though. Let me try
maybe
something
you
here.
could just read what each LCD pin says in the manual, and we can verify on the circuit board.
Okay, so pin 1 is ground, pin 2 is VDD 5 volt, So pin 1 is
So
ground, and this is based on.
let's look at each one of those and make sure that they're correct.
Okay, so pin 1 is ground. So this one here. And starting from this side, I can tell because of the mounting hole right there is kind of indicating which one it's closest to, because the mounting hole is quite far away on the other side.
Yep, that checks out.
Okay, so pin 1 is ground, and that is correct. That's going to the right pin. Yep. Pin 2 is 5 volt, and that is going to 5 volt. Pin 3 is contrast adjust 0 to 5 volts. So,
looks like that one is the one running off to the potentiometer.
Yep, going to the center pin of the potentiometer, and I'm just going to verify that potentiometer is not installed backwards, which it is not.
It seems like the contrast adjustment was working
Yeah.
when you had it plugged in.
So
Also,
and then
potentiometers are not polarized, so.
Oh, okay. So this is where I think I could have messed up. So 18 and 19. So the next one after the potentiometer is register select and read write select. So pins 4 and 5. So pin 4 is supposed to go to pin 13. It doesn't say that anywhere in here, but I can verify that in here. So pin 13 goes there. I wish I could look up the library. Oh, it's probably. Oh, cool. Thanks, SparkFun. There's you can view circuit diagrams and instructions here. This is nice. Okay, so this is cool. So here's that bit we were just talking about. So this should go to pin 13, following that here. So that's going to the right spot, and then pin 12 goes to pin, I think it's 6. Oh, we miss register select. 1, 2, 3, 4, 5, 6. Oh, yeah.
It's like register select should be tied to ground.
Yeah, we're missing one. Yep, we totally are. We found it. So, I'm sorry I'm like too focused on what I'm trying to do here to remember what the camera's pointing at. So, that's out of focus, but I'm going to move this pin here from pin 5 to pin 6. 2, 3, 4, 5, 6. Yep. And I need to add another ground. Now, when I make a mistake like that, how likely is it that I'm going to burn something out?
Pretty unlikely.
Really?
Well, it depends on the circuitry that you're hooking up. For something more on the complex side like this, I would expect there to be some reverse polarity protection, but I guess I don't know that for sure.
Yeah.
On like really simple parts like LEDs and stuff, the chance is much higher.
Hey, we got it. Yeah, because I mean, I've burnt an LCD before, or an LED before, for sure. Cool. Okay, so that's displaying a thing. So, okay. I think this is a good example of hubris, of me saying that I was comfortable with breadboards. I flew too close to the sun and missed a pin.
I mean, debugging is in an insanely helpful skill to have. And how do you get better at it if not by practicing? So
For
so it's
proper
useful.
debugging, we probably should have continued on our check and double checked all of the wires, even though we found a mistake, or was it good to just test that one?
Yeah, I would say it would technically be the best to just recheck everything. But if I'm writing software and I find a problem, I'm just going to immediately recompile after
Yeah.
fixing that first problem and not just go through and check everything I've already written. So it's a perfectly natural reaction just to say, "Oh, found the problem.
Found
Let's
it.
try it again."
There's your problem. Cool. 940. Where did I put that? I feel good about this. This is cool. Let's see if I can actually find the. Oh, it has the drawings in code. So that's not actually useful to us right now. What is the serial thing doing right now? Serial monitor. Nothing. There's nothing writing to serial here. So what is it showing? So this is print the number of milliseconds have passed, a number of seconds that have passed since the last reset. Okay. That's cool as heck. And it looks neat too. I have an old, I'll have to find it. I have a a belt buckle that you could program what it would say, and I'm interested to take that apart or see if I can hook that up to a microcontroller at some point.
That sounds hella neat.
It has it's pink. It's a pink LCD display with little rhinestones around it, and I'm pretty psyched about it. So maybe I'll dig that up before next time if we can get through this. This still doesn't make like a huge amount of sense to me because so much is just happening in the background with the library. But
Yeah,
um,
we could dig into it a little bit if you wanted to, or we
yeah,
could just move on to the next project.
let's dig into it. And so I would look up this library.
Yeah. See if it's
Okay.
a part of the Arduino reference library or if it's something else. Oh, it looks like it's a part of the reference library.
Liquid crystal library. Okay. So, okay, that is camel case. So auto scroll, blink, cursor, display, hello world. These are different projects, looks like. That's
Yeah, it looks
cool.
like example projects.
Oh man, so you're telling me I just want to look at another library quick. I'm just gonna pick one. Yeah, SPI, we were just talking about that. It explains it. Oh, it does have some examples.
Hmm.
So showing example projects for it. That's cool. Okay, back to our programming here. Okay, so
So I remember you had a question about the order of the parameters in the constructor. So let's
yeah,
click on that first one, the liquid crystal function, which is the
okay,
constructor for the class.
yeah.
So we see here there are a few different options that you can use for this for the constructor.
Mm-hmm.
It looks like we are using the first one. Is that true? So this differs in the number of inputs that you can provide for each one.
Yeah, so I'm providing. So that's just the number of pins, or
Let's bring up the code actually.
oh, okay, I see what you mean. So this has 1, 2, 3, 4, 5, 6.
Sure. So we have 6 inputs. That means we're using the first one of that list, and it looks
Yep.
like so you see here. There's a specific order prescribed. The first input
Mm-hmm.
indicates the which one is connected to the RS pin. The next one indicates which Arduino pin is connected to the enable pin. Um,
What does RW and RS mean?
I don't know. Register select and read write,
Okay.
maybe that would be my guess.
That I think that checks out.
I'm not 100% sure.
Yep, it does. Yep. So, so then that's digital 4, 5, 6, and 7.
Yeah, then those would be the 4 data transfer pins.
Okay.
So basically this is prescribing the order that you have to supply the, the pins in the actual code. So like in
Sure.
your project, pin 13 is the RS pin, pin 12 is the enable pin, and so on. 11 through 8 are the D4 through D7 pins.
So 8, 9. Because there's 4 of those. 8. And so what do these numbers do? Like,
I would suspect that those are a part of the digital interface to actually send data to the LCD. That description seems to state, yeah, that those are the data lines.
okay. Okay, so you can just. So it's not like I'm doing any pulse width modulation or anything like that.
No, I think these are just straight up digital
Okay.
outputs.
We have someone in chat saying try serial.begin.
Yeah, so you could set up, if you wanted to set up something on the serial monitor.
Oh. Yeah, where do we do that? I could look at an old one of the other projects, right? And see how they did it.
Yeah.
I think the motion alarm had it. Serial print like this?
Yeah, so what we'd have to do
Oh,
first is
serial begin,
we
right?
would have to import the serial library, the serial header at the top of the file. Or no, maybe it is native, my mistake. So we don't need to import anything.
But it is the serial begin thing here in the
Yep.
void setup.
Yeah.
Make sure I don't have any cords touching my keyboard. I was pressing the over key quite a bit not too long ago. Void setup. Excellent idea. Oh, you're saying no? I don't know.
Yeah, if you insert a serial.begin here,
Okay.
that would be the first step to getting the serial monitor going.
Okay, and then we'll have serial print and the void loop. Let's have it print no serial print. Copy it to setup. Oh, and it should just work. Just having it in setup should do something.
Yeah. If you were to stick like a serial.print or something in the loop.
Okay. The
Now, yeah, you don't have any prints going on here, so you opened the serial connection, but you're not actually printing anything to it currently.
Okay, series. I don't understand. Some programs need it. So they're saying copy it to setup, no serial print, no just to initiate. Oh, just serial begin. Oh, okay. In the void loop or in the loop.
No, don't do another serial.begin in the loop. You
Oh,
only need
because
to
it's
do it
already up
once in
there.
the setup.
Okay.
Maybe try doing a serial.print line down where we're printing to the LCD
Yeah.
and just print like the same value as an example.
Okay. Could I have it print what the LCD is printing, or would I need to incorporate another variable there too?
You could. I would say you'd have to just put what is in the input to the
Yeah.
LCD.print into the input for print. Now there is There is a distinction between serial.print and serial.println, println.
Oh, okay.
Print will just print whatever is in there, just straight to the serial monitor, and
Okay.
println will print what's in there and a new line character at the end.
Oh,
So
in
if you
case
wanted to
something
like have
changes, yeah.
things just like written out one right after the other without inserting like a line break or anything, you could use
Yeah.
serial.print.
Like if I was using Serial for like monitoring the current status and didn't really care about the previous statuses.
Um, maybe, yeah. Truly, the only difference is that print line will just automatically move down to the next line.
Okay. Neat. Cool. Yeah, that's good. I like that. So if I wanted to do this so it would just mimic what it was printing, I would set this hello world to a different variable and then call the variable instead for LCD print and call the same variable for serial print.
I think that sounds correct, yes.
Okay, cool. We were looking at not the logo staying, that's different. What are we looking at? Arduino, okay. So okay, so those are just data pins. So those aren't actually, those are just sending, it knows how to interpret the data coming in from those 4 pins. There's no real rhyme or reason to like any data inputs or outputs or anything like that, or is it sending bytes or?
Strongly suspect that it just uses those data pins as a part of some sort of digital interface.
Okay. I think that's another concept that kind of escapes me is how can you have, like, I understand the ons and offs and the pulse width modulation, but the simultaneous use is like a digital input and output is kind of doesn't really make a lot of sense to me.
Okay. Digital input and output would mean that it only ever operates in the high and low or true and false sense.
Yeah. Okay.
It's all ones and zeros. Whereas the analog stuff is that a whole range,
Yeah.
of values between your high and low.
Yeah. How do you transmit so much information? Like how does it translate this into showing up in the LCD with just the ones and zeros then?
Sure.
Is that bytes and is that data?
Yeah, there's a lot going on under the hood here. I would suspect that the library is just taking each character, converting it to some corresponding byte that, like, converts it to ASCII, for example.
Yeah.
If you're familiar with that character representation, and uses the data lines to transmit that byte to the LCD, which then takes that data and interprets it and causes that character to show up on the display.
So this display is probably pre-programmed with all, UTF-8 probably.
I strongly suspect that
Characters.
there's a microcontroller somewhere on there under the hood that is driving the LCD, interpreting like the digital interface and doing a lot of the heavy lifting to get those characters to show up.
That makes a lot more sense to me. So there's, it's a communication between 2 different complete units. So this has the decoder on it.
Yeah.
Okay, that makes more sense to me. I never actually tested it. No, it did not work. Serial is not declared in the scope.
I think it needs to be a capital
S. Yep. Whoopsie daisels. Where is my serial monitor? Yep.
So there's that. It's failing to print a new line character.
It's working great. We are successfully printing Hello World. I understand the new line thing a lot better now. Um, uh, good. It does seem to work kind of. So let's change that a little bit to print line. And yeah, hello world. Is everything okay? Let's try that again. Um, there we go. That's better, right? I think that's better.
Yeah, easier to
Yeah.
read.
Okay. Thank you, Oka series. Oka series. I think that's. I don't know how to say that. Thank you so much though for the recommendation because it I kind of was curious as to why there wasn't a serial thing there. I see now that although I can do it, doesn't mean I should do it because it's just printing "Hello World" over and over again. But yeah, thank you for the guidance on adding that there. I kind of want to get used to remembering some of this stuff off the top of my head and not just stealing from previous projects.
Yeah.
But
I think let's do another little coding experiment here, right? You had
okay,
kind of
yep.
alluded to this before about creating a variable and
Mm-hmm.
supplying it as an input to both of the print functions.
Mm-hmm.
So let's make a new variable inside of loop that is
Okay.
an integer to store that millis divided by 1000 value that is being supplied to lcd.print.
Okay.
So like an int, call it something like, I don't know, think of a good name.
Um.
It is the number of
Later.
seconds that the Arduino has been running.
Okay. So timer. Right. Let's
Yeah, that sounds
start.
great. And
Okay.
then let's set that equal to that value that's inside of the lcd.print right now, millis divided by 1000.
Do I just do? I'm like forgetting how to do ints right now. I need to load up another sketch.
Yeah, that's right. This is you're declaring a new
New.
variable that is an integer, and you would need to set it to be equal, an equal sign
Sure.
to that value that's in there. And in this case, you wouldn't need the parentheses,
Oh.
but you can have them if you wanted to. Just like this is now like a math equation essentially, so you could have the
Okay.
parentheses to just indicate order of operations. Um, and then now that we have this new variable, let's put it inside of the lcd.print and the serial.print line.
Sure. Um. Right.
And it will yell at you for no semicolon on that new line that you added.
Oh. Good eye.
Years of practice.
Yep. Cool. Yeah, it's counting up. That's great.
And then
So
it should, on your serial monitor, it should be printing basically the same thing that you're seeing on the LCD. Oh, oh, there it goes.
yeah. Once a second. Huh. Okay, cool. In general, is it good practice to set things up as variables or avoid it? Like you're
Hmm. It is usually good practice to set things up as variables if you ever need to use it more than one time.
okay.
So, for example, like in this example, I would not think you would need to set hello world to be like a variable and then supply
Yeah.
that variable to the LCD.print
Mm-hmm.
because you're only ever wanting to print hello world a single time or use that string a single time.
Mm-hmm.
Whereas, like for the timer, we set it up as a variable because now we want to use it in two places and we don't want to just be
Right.
copy pasting that millis divided by 1000 everywhere.
But if I
Um,
had if I had an array with different words in it and I wanted to call the array I would put the array variable in that spot, right?
You could do that, yeah.
I would set the
And
array to a variable and then put that
yeah,
variable in the print.
yes, I think so. And so, like, the reason that this is nice now is that, say you wanted to change how the timer gets calculated, say you wanted to display the timer in minutes or hours or something like that. If you had copy pasted millis divided by 1,000 in a few different places, you'd have to go and change each one of those places
Mm-hmm.
to use the new equation. But now you can just change it in the one spot
Yep.
and it automatically is propagated to all the places that it gets used. So
I use
that's why I
that.
say usually you want to, if you're using it more than once, set it up as a variable.
I use that concept a lot with the work that I do, so it's good. Just like shared libraries and um, like universal components on a website versus just on-page components. If you're going to have a universal piece of content that's going to appear on multiple pages, you don't want to edit it on multiple pages. You want to edit it in just one spot and have it propagate. That's kind of what
Yep.
this is, right?
Yep. I think so. Hmm.
Cool. Well, we are at 10 o'clock. I think we should call it because since I'm interested in this next step, I could dive deeper, and I don't have time for that right now. So, our next project is 4B. We're going to be working with a temperature sensor, which is rad because I do want to do things with a temperature sensor. One of the projects that I wanted to do also with this was one of the motivational pieces was to report on my Twitch channel how cold it is in my basement. So it would be interesting to try that out, play around with that sensor. Once again, thank you so much, Zenhaver, for your help today. Not as many rapid fire questions today, but I think there's still quite a few concepts that we were able to cover. Even just like simple debugging and a little more involved use on these libraries. So thank you very much.
Yeah, absolutely. It was fun.
And next week, yeah, I'm excited to dig into the rest of it. I think we probably have, probably 2 or 3 more of these left for this kit. So, cool. Yeah, we're over halfway through though, so this is rad. So, thanks everyone. What's going on? Are there any streams tomorrow? Next time I'm streaming is on Tuesday. I skipped last week. Took a little bit of R&R. Yeah, you're welcome, V.E. Kruger. V.E. Kruger, do you know of any streams that I should shout out happening soon? Or if anyone in chat wants to shout out any streams that they want to people to check out, please do. Oh, V.E. Kruger is playing Stardew Valley tomorrow, and Zap is playing Outer Wilds tomorrow. So you're in the early morning with Stardew Valley, right? Correct? Some top of the morning farming. Oh, 6:30 p.m. Okay. I for some reason interpreted that as 6:30 a.m. at some point today, but okay, so 6:30 p.m. Stardew Valley with V.E. Kruger, and then after that, Zap is going to be playing some Outer Wilds. Yeah, meetings are the worst. So thanks everybody, and we'll see you soon.